Welcome, everyone. Thank you for attending this session. Fabric Real Time and CDC, Ingesting in Real Time from Azure SQL. My name is Dennis Torres, and let's talk a bit more about. Let me introduce myself. This is me. I'm a former data platform MVP. I'm, I work on the Tower software and provide access to Onyx data. I'm a trainer with many Microsoft certifications and I live in Malta. And I'm the leader of the Malta Data Platform User Group. I'm always organizing technical sessions here in Malta. You can see my contacts on the right side of the screen. It will be a pleasure to stay in touch. So feel free to connect on social media. It will be a pleasure to stay in touch. Okay, so the agenda today, we have some items that we'll cover today, but what exactly are we talking about? Some of you may already understand what I'm talking about when I mean CDC, but I will start from the beginning for everyone. So the point is, sometimes some scenarios require the ingestion from Azure SQL to really be in real time. It's not about to have a huge amount of data. It's about to be able to have the data visible immediately as it is updated in production. So have this ingested really in real time or closest to real time as possible. And the solution for this is to use what we can call a CDC streaming, a CDC provider for Azure SQL. And it's not for only for Azure SQL, as I will illustrate, but Azure SQL is one of them. So let's go into details about these items. Let's talk first about the ingestion from Azure SQL. What do I mean? What are the possible methods we have to ingest data from Azure SQL into Fabric? We can use data factory pipelines. We can use data flows generation tool. We can use notebooks for the ingestion. We can use mirroring. And now we can use SQL CDC streaming using the providers for SQL CDC in real-time ingestion. So some of these ingestion methods, they need to be scheduled. That depends on a schedule to be executed continuously. And according to the schedule, they go to Azure SQL and they bring new data from Azure SQL. The fact that an ingestion method depends on a schedule makes that it's not real time. It will also always have an interval to update the data. It will always have some kind of interval to update the data. For some business, this is more than enough, but for other business, this is not acceptable. They want to get closer to real time as possible. So how do we solve that? First, one important thing to highlight is that we are talking about ingesting from Azure SQL to Fabric. Azure SQL, in general, in this scenario that we are talking about this, Azure SQL is the production environment of the company, the daily systems of the company. This means that these daily systems have a modeling, a database modeling focused in the production area. And usually they are not focused in keeping history of the data. When we bring the data to Fabric, we want to achieve exactly the opposite. We want to have the history of the data. We want to keep a good history of the data and not lose the history of what happened before. How do we achieve this? using a technique, a modeling technique called slowly changing dimension. So it's not only about get a table customers in Azure SQL and transfer to a table customers in Fabric. Not only that. It's about changing a bit the modeling in the way that the table customers in Fabric will be using what is called slowly changing dimensions. This modeling technique is used for dimensions, not for fact tables. Dimensions use this technique. So, what is slowly changing dimensions? In production, we are used to make inserts, updates, and deletes. We always make this kind of operation, the general crude operations in production. But in data intelligence, either data warehouse, lakehouse, the idea is that we only make inserts. We will not make deletes, we will not make updates, we will make inserts. At any moment, if we make a delete or make an update, we are losing the history about how production was at a specific moment. At a specific moment, production was in that way. And we wouldn't like to lose this history. So we use this modeling technique to solve that. So when a record is updated in production, this generates a new version of the record in the data intelligence. So the records are always being inserted. The records are always being inserted, but I have a version control of the records. Multiple versions of each record are kept. When I say each record, I mean the key of the record. Key. When I say key, I'm talking about the primary key in production. The primary key in production is still a key for the objects, but is not exactly the primary key of the table in a data intelligence environment, exactly because we will be using slowly changing dimension. Because when the record changes in production, we insert a new version of the record in the data intelligence environment. So the production primary key repeats itself in the data intelligence environment. And we keep multiple versions for each primary key, each production primary key. Only one version of each production primary key is the current one. So we need to point very clearly in our records which version is the current one, the current state of the production, while every previous version needs to be marked with the information about when that version was valid in production, when that version was the reality in production. In this way, we keep a very detailed history about our data by using this modeling technique. There is no automatic SCD solution. There is no automatic solution that brings a customer table from production and creates an SCD customer table in Fabric. This doesn't exist. So we need a special processing during the ingestion. During the ingestion process from the source to Fabric, we need a special processing to keep this history in a slowly changing dimension. Let's say an example. Here I have one record. One record where I have a customer, Johnny Caprio, and I have some additional fields that are control fields for the SCD modeling. These fields are the start date when this record became valid in production and the end date when this record was not valid anymore in production. When the end date is null, this means that this record is the current one in production. This record is the current value record in production, current value version in production. This 12 here is the customer ID. So I can have many records with the ID 12, but I can only have one ID 12 with a null value on the end date of the record, illustrating that that record is the current version active in production. So let's imagine that this record is updated in production. So we get a new version of the record. Uh, Getting a new version of the record, what's the processing that happens when inserting a new version? We go to the previous version, which was the current one, Johnny Caprio, and we update the end date. So this version is not the current anymore. So we need to go to the end version and update the end date. And then the new version becomes a new record. And we have here we have here the start date of the original record, and now we have a finish date for the original record. And the new version becomes the current valid record, the current version of this record in production, illustrating the current version of this record in production. And there is an update. What was updated in this record? The first name of the customer. The first name received an update. So the guy was called Johnny and the guy became Johnny 4. The first name was updated, and we need to express when it happened, when it became valid, and that this is the current state in production. So this is the current state and became valid at this date. This is how a slowly changing dimension works. So some of you may already know how slowly changing dimension works. So for some of you, this is like a review. You know. But this will be important for the comparisons I'll make in relation to the technique we will talk today. So let's talk more about ingestion. Ingestion and scheduling. This I was mentioning before. Most ingestion methods need to be scheduled. And scheduling means that an interval between executions will exist. If we have this interval between executions, the ingestion is not really in real time. So it may support some scenarios, but there are scenarios that are not supported by this kind of solution. So scheduling is not enough. Okay, what ingestions are potentially real-time ingestions into Microsoft Fabric? I mentioned two, mirroring and CDC. These two ingestions can reach a real-time status from Azure SQL to Fabric. So both ingestions can reach this. And what's the difference of these ingestions? To understand the difference of these ingestions, let's talk a bit more about what CDC. CDC comes from Change Data Capture. Is a feature from the source. Many databases have this feature. Azure SQL by itself may have about three different ways, three different methods to use CDC, technically speaking. But what's important is the capability to identify a change in the source database. So the source SQL server provides the information about every data change. So we get the information about the operation that happened, the records which were affected by that operation, and the data related to that operation. So CDC in SQL, CDC enabled in SQL provides us this information for every operation happening over the data. Talking about a very basic architecture, and this is not what we are trying to achieve today. We will go beyond that. You could just enable CDC in Azure SQL and query the changed data from a specific moment. During many years, this was a very usual architecture, and there are technical articles in Microsoft Learn Portal explaining how you do that. For example, how do you query the CDC from an Azure Data Factory, for example? There is this information in Microsoft Learn website. So you could just go to SQL and query the CDC. But that's not what we're trying to achieve today. Because if we need to go there and query, we need to do this in a shadow way. If we need to do this in a shadow way, it's not real time. That's not what we are trying to achieve. But an interesting point about CDC is that the incremental ingestion is possible. In any way that we use CDC, we are doing an incremental ingestion. We are receiving only the data which was modified. We have no need to, like in some ingestions, we have no need to read the entire source, get the entire source, discover what changed, and ingest in our destination. This doesn't scale. This kind of solution to read the entire source doesn't scale at all. And CDC has the capability to make incremental ingestion. Okay, but now let's talk about what CDC is streaming. Mind that I established a difference between the CDC by itself, that we could go to Azure SQL, enable it, then we could keep pulling it, querying it to get the changed data. Yes, we could. But there is what is called CDC streaming. What is this? This is usually implemented by some tool that makes a real-time ingestion of the CDC information from Azure SQL. So, in the moment that a record is updated in Azure SQL, the record change, the CDC information is generated, registering the change, and this information is sent to the event stream. In this case, we are already talking about an event stream in Microsoft Fabric. It's when the source SQL Server sends us the CDC updates in real time. Event stream has what is called a SQL Server CDC source. So we can enable CDC in Azure SQL, and we can use this Azure SQL CDC source to get the CDC information in real time. So once the CDC happens in Azure SQL, once an update happens in Azure SQL, we will receive this update immediately inside the event stream. So we receive the data in real time. Yes, we receive the data in real time, but we still need a processing for the CDC ingestion. What do I mean about processing? Because the customer information in production is modeled, the database model is according to production, while the customer table in the data intelligence store needs a modeling more according to the data intelligence store. And one of the main differences is the SCD, the slowly changing dimension. So to implement the slowly changing dimension, we need a processing. We need to receive the CDC information and make a processing to insert the CDC information into the tables in our storage, like a lake house or data house, for example, uh, respecting the modeling of a slowly changing dimension. This is not automatic. We need to implement this processing. Oh, but we'll be using an event string. Can't we implement this processing totally inside the event string? Not today. Not today, because it's part of the slowly changing dimension processing that we need to finish, put an end on the previous value record. We need to put an end on the previous active record, which means an update on a record which is only in the lakehouse, for example. The event stream doesn't do that. The event stream does transformations over the data it receives. It doesn't go to the lakehouse to change a record which is already there. So we need a specific processing for SCD ingestion in this situation. Let's talk about difference between streaming CDC and mirroring. I'm comparing a lot of streaming CDC and mirroring because both can achieve real time. Mirroring also will bring the data in real time to inside Microsoft Fabric. Both will achieve real time. But what's the difference? How do you choose which one you want to use? Both achieve real time, but mirroring doesn't bring a history and doesn't provide SCD, slowly changing dimension. While the idea of using streaming CDC is to keep the history of the data and build a slowly changing dimension on the destination. By using CDC, we can do that. Someone could argue, oh, but we could do that in mirroring as well. Because I already said that to achieve this in streaming CDC, I need to put an additional processing. Why I don't put an additional processing mirroring and achieve the same? Because if I try to make this processing in mirroring, means that I need to, from time to time, get the entire mirror table, identify what changed, and get the change, extract the change to inside the lakehouse. This would be a considerable work in something that was not done for that. So mirroring is not intended for that. While in CDC, we are already receiving the changes. We are receiving records that specify exactly changes, inserts, updates, and deletes that happened in the production table. We just need to act according to these changes over the table in the lakehouse. Oh, but do I need hours to implement SCD when using streaming CDC? Well, if you don't need to implement CDC, if you don't if you don't need to implement slowly changing dimension, if you don't want to implement slowly changing dimension, then use mirroring. Mirroring is easier. Mirroring brings the data for you with no history. The problem is that not having history. For example, production environments are used to drop records. Production environment drop records. Then the record will be dropped in the fabric side as well. And you lose that information or don't have that past information anymore. While the idea of the streaming CDC is to keep history by implementing a slowly changing dimension. If you try to implement streaming CDC without keeping a history, is it possible? Of course it's possible, but why? It's much more difficult than mirroring. Mirroring is way easier. In the same way, if you try to implement a history and implement a slowly changing dimension, why are you going with mirroring? Because it will make the additional processing extremely difficult. Go to streaming CDC. So you have these two technologies and each one have its use case, and its use case is directly related to your need of history information, your need and desire to keep history information and implement these slowly changing dimensions or not. That's why explain it in details. I review and then explain it in detail what the slowly changing dimensions are. Because this is the decision point between using streaming CDC or mirror. Now, let's go deeper into the technology and talking about setting up the streaming CDC. How do we set up this? Let's start from the Azure SQL. Azure SQL requirements. The Azure SQL needs to be level S3 or above. Only level S3 or above can have the CDC enable. You can't enable CDC in a lower level than S3. Doesn't work. So this is a requirement for the Azure SQL. So you need to enable CDC. Yes, you need to go manually to Azure SQL and enable CDC in Azure SQL. This is required. This is a requirement. Well, this feature is still in preview. During this preview stage until today, only basic authentication is supported. This feature to make a streaming of the CDC to an event stream in Fabric only supports basic authentication. If you want to make an authentication with an Azure identity, you can't. The feature will not work. So only basic authentication and more. The permissions that this basic authentication needs to have are very high. Mostly I would put it as a system administrator, an assistant administrator in the environment of the Azure SQL. So in this preview stage, this is required in this feature, but it's a preview stage. Keep in mind, this is a preview stage. The event string. Yes, we'll just build in Fabric an event string, and the event string will receive the information about what is changing, what records are changing in Azure SQL. So the event string requires enhanced capabilities. This feature needs to be enabled. Both features are in preview. What do I mean? Both features are in preview. Enhanced capabilities is also a feature in preview inside Microsoft Fabric. So the enhanced capabilities of Event Stream is in preview, and the SQL CDC provider is in preview. We are talking about preview feature, but there are some courageous ones, like me, for example, that like to risk and implement something beautiful like this in production. I do so. You can choose to ingest all tables or specific tables. When you are building the connection from the event stream to Azure SQL using the CDC provider, you choose. If using the CDC provider, you ingest all the tables, you get the changes which are happening on all the tables or only on specific tables. So you do that during the event string configuration. And the tables need to be enabled for CDC. For this to work, the tables need to be enabled for CDC. JSON snapshot. What I'm talking about? Well, all the communication from Azure SQL to the event stream will come in JSON documents. All will come in records in JSON documents expressing what is happening on the side of Azure SQL. And we can insert these JSON documents in a custom database. For example, we are talking about real time. We can ingest them in custom database and then make the processing of them from the custom database. But when we first configure the source and link the source to the custom database, the CDC provider starts a processing of a snapshot. So the CDC provider takes a snapshot from our existing tables. Why? The reason is very simple. If this provider is about to give you all the changes that happens on the table, what will you do with the change information if you don't have the table? If you don't have the original values of the table? So, unusual and basic solution that we would do in the past is that we would need to make a first ingestion of the tables to the lakehouse. We would need to ingest the tables to the lakehouse first, and then it starts to hash the changes coming from CDC. However, to make this first ingestion even easier, this first ingestion is being delivered through the CDC provider. The CDC provider takes a snapshot of the table and gives you this snapshot of the table. So, when starting, a snapshot is taken. When the CDC provider started, takes a snapshot. One JSON document for each record, each pre-existing record in the tables in Azure SQL. So a snapshot will be taken from the tables in Azure SQL, and one record will be provided for one JSON document will be provided for each record. There is a very important field that comes in the JSON. This is a field called operation. When a snapshot is being taken, the records, the documents arrive in the event stream with the operation defined as A. This is the operation for the pre-existing records, the records which were there already, and just need to be used to create the initial table in the lakehouse environment. All tables are included. All the Azure SQL tables are included on this snapshot, and these are not only the filtered tables. I said that you can filter the tables and choose which tables you will ingest, but the snapshot includes all the tables, even tables that are not CDC enabled. The snapshot includes tables that are not CDC enabled. In my personal opinion, this is probably a bug in the preview feature. I don't see much sense to include a snapshot of tables which were not selected to be ingested and which are not CDC enabled. I don't see much sense about this. So in my personal opinion, this is a bug in the preview feature. But let's see how things evolve. This is an example of the format of the JSON, and this is highlighting at this point what I said. I said the field is operation. In fact, is OP, the name of the field, and comes with value A when we are receiving data from a snapshot. When the provider for CDC ingestion was just enabled, and we are receiving data for a snapshot. And the information about the source, here on the source item, we have many details about the source of this data. And the information about the source includes a snapshot field that has a Boolean value telling if this record is part of a snapshot to make the initial creation of the table in the lakehouse environment, or if this record is already a changing operation being delivered to the fabric environment. Okay, and in relation to the ingestion itself, let's consider the snapshots happen, finish it, and now about the ingestion of the changes. One document or row is ingested for each change happening in the Azure SQL environment. Each change happening in the Azure SQL environment will generate a document which will arrive in the event stream. The operation value will come as C, U, or D. Create, update, or delete. So this tells us which operation was done with the record. So we receive JSON documents telling us which operation is being done with the record. In this example, you see here, the operation is specified as U. This is a record representing an update of a record in Azure SQL. The snapshot field in relation to the source tells us that this is not a snapshot anymore. This is the record of a change. This is the record of a change in data inside one of the tables. An update happened in Azure SQL and this record was generated. And we always receive a before object and an after object. This means how the data was before the operation and how the data was after the operation. In an update, both are important. In an update operation, we have what was the record before and what was the record after. In some special situations, in some special requirements, we may need to compare the before and after and discover which fields were changed. Some situations may not require that, and we are capable to implement the SCD without making the field comparison. But in some other situations, we may need to make the field comparison and discover which fields were changed, and we can. If the operation is a C, a create, only the after fields are important. The before fields will come null because there was no before. The record is being created. If the operation is a delete, in this case, only the before fields are important. There is no after field after a delete. The record will disappear from production. So we receive the operation and we can navigate on this JSON to process this JSON and update our tables in the lakehouse. So the after ingestion processing. Let's talk about how do we process this JSON. How do we build the processing of this JSON? I'm talking a lot in this in theory, but I'll show a fully functional scenario, and I'll show this scenario how each piece connects to the others in a moment. So let's talk about the after ingestion processing. We can apply different techniques, different algorithms, so it varies a lot. There is not a rule set in stone about what needs to be done, about how to do. What's important is the end result. The end result is to achieve the dimensions being ingested in SCD format. This is what needs to be achieved. So, after ingestion process, it's possible to process multiple tables. We may have enabled multiple tables for CDC. So, we are receiving together in the same event stream the information from multiple tables. In this case, our script needs to be generic and needs to be capable to break down the records according to the table they are referring to, and then process each set of the records according to the table they refer to. You need a control table for ingestion. What do I mean? I mentioned before, the event string will be ingested into a custom database. Then you make this after ingestion processing over the table in the custom database. Okay, but for each execution, we need to be sure that we never get the same record twice. If we get the same record, the same change record twice, we will create mistakes. So we need to be sure that we control the ingestion process. We need a control table for the ingestion process, basically telling us what was the last ingestion date that we got. After executing ingestion, we save the last ingestion date that we got, and then we start from that date. Custo is the source for the after ingestion process. Yes, custo is the source. A notebook is needed because the, sorry, this is an error in this slide, because the SCD, of course, the event stream is capable to make some transformations of the data directly inside the event stream. The event stream is capable of that. But there are some transformations required for the slowly changing dimension that we can't implement today in an event stream. So we still need to make this post-processing post-ingestion implementation in a notebook. The notebook can be shared. Yes, that's a possibility, and that's the weak point of this solution. Because if we decide to run this solution with a shadow notebook, in the end, we are not really making a full real time. We are still depending on some shadow execution. We are not fully in real time. That's a fact. I believe, I believe that some improvements to the event stream will come that will allow us to not have this need to shadow the notebook. The data could come directly from the event stream and trigger the execution of a notebook without a shadow. But today, we already have an alternative option. We can use a data activator technique to trigger the execution of the notebook. I wrote a small, or could say a blog post about how this technique works. And I'm using this technique for some scenarios. I will talk about this. So what is this data activator notebook execution technique? The idea of this technique is that we want to avoid scheduling the notebook. We want the notebook to be triggered when there is data for this notebook. We want to avoid the notebook to be scheduled and keep running over and over and over again. So we have an event stream. The event stream will drop the data into a custom table. Okay. And we have a lakehouse. The lakehouse is the final target of our data. Our data will be in the lakehouse, and I mentioned before that we need an ingestion control table. This ingestion control table can be in the lakehouse as well. This table can be in the lakehouse as well. So we join the result in a real-time dashboard. Why? Why do I need a real-time dashboard? Well, the real-time dashboard is not the end result that we want to achieve. The point is that we need a real-time dashboard to create an alert. Sorry. We need a real-time dashboard to create an alert over a query that between Custo and the lakehouse. So we can create a query that defines, is that data for the notebook to process? And you create an alert over this. An alert, in this case, is a data activator reflex object. So we create a data activator reflex object to handle this situation. And the reflex object can analyze the result of this query, the query that question, is there something to be processed? Was there any change on the data? Is there something that needs to be processed and taken to the lakehouse? When the reflex object identifies, oh yes, there is, the reflex object triggers the notebook. The notebook will read the information from the custom database, will send the information to the lakehouse, updating the lakehouse. And this will become a constant loop because according the event stream drops inserts new information in the custom database, the reflex object will identify there are new information for this notebook to process. The notebook needs to process new information. And the notebook will be executed again and again and again without a shadow. The notebook will be executed when there are data, when there is any data to be processed and not based on a shadow. This is an interesting technique. I use this technique for some other purpose, and I'm intending to use for this ingestion as well, this kind of ingestion, this ingestion as well. The only problem of this technique is that the data activator can have a delay between 5 to 10 minutes to trigger an execution of the node. So again, we are not fully in real time. We are close to real time, but we are not fully in real time because the data activator has a delay to trigger the notebook. As I mentioned before, I expect this to change in a close future. I expect this to be changed in a close future. Now that we talked about how this theory details, let's see these objects. Let's see how this works. So I said I need a source. I need a source which is an Azure SQL. So I have here an Azure SQL which is used as source. The table that I selected to be ingested to enable for CDC is the table customers, sales LT customers. I need to enable CDC on the Azure SQL. So SP CDC enable DB. And I need to enable the table for CDC. Then I need to configure the event stream in Fabric. After configuring the event stream in Fabric, I executed some changes and an insert to generate change records on the Fabric side. So some change records were generated in the Fabric side. So let's go to the Fabric side and see how this is built on the Fabric side. This is the event stream. See, it's extremely simple. It's an extremely simple event stream. And Uh, it appears that it's an Azure SQL DB source, but it's not an Azure SQL DB source. It's an Azure SQL DB CDC source used inside an event stream. So this is reading CDC data, change data, capture data from Azure SQL. Let's take a look on the details of this configuration. The target is the custom database. There is nothing new on this. But the source is the CDC. And we find here the configuration that I mentioned. I can select here if I will ingest all the tables or if I ingest only some tables. And in this case, I selected to ingest only the customer table. So only the customer table is being ingested in my Fabric environment. The connection is using basic authentication with a sysadmin login. This is required for CDC. Let's see what we have in the custom database. Let's take a look here. I have a table here, which I call Fab CDC. And this table was created by the target on the event stream. The event stream target created this table called FabCDC. Then I can execute this to query the FabCDC table. And I can see here um, 4 records. These 4 records, they are the 3 updates and 1 insert, which I made. Remind that I mentioned that the insert would have the before null. Hey, this is the insert because it has the before null. So I receive the payload in JSON format. We can analyze that. We can get this JSON and analyze this JSON, for example, in JSON hero. I can ask to visualize better this JSON. And we have here exactly what I illustrated on the PowerPoint. I have the operation U. This is a record for an update. I have the before fields, which are the fields for customers, the before fields, which are the fields for customers before the change, and the after fields, which are the fields for customer after the change. The source points the name of the table. Name of the table in schema is showing the source table. So if we are reading from multiple tables, we need to break down the records in sets for each table. And this is not a snapshot. The snapshot records come only on the beginning. This is not a snapshot record. It's already a change record representing an update of an information which happened in Azure SQL. Update of information. This was generated by these updates that I executed in Azure SQL, in my Azure SQL environment. Okay, so let's take a look on the lakehouse. I have a customer table. This customer tool you can ignore. It's just a safeguard for the demonstration. I have a customer table here. And I have a table called ingestion control. The ingestion control has the last date time of ingestion for each table name. So in this way, we control the records which we already ingested from custom into the lakehouse. Okay. And I can query the customer table. So here is the customer table, basically the fields for customers. And here at the end, we have the fields which are used for a slowly changing dimension, in special the W end date and the W start date. What we can notice is that there is no DW and date already fields. There is no record that has changed before. This is the original table inserted in the lakehouse. And the primary key also, there is no duplicates because this is still is the original table inserted in the lakehouse. Okay, then I need to make the processing of the ingestion. Um, Sorry, just a moment. It's not this notebook. This notebook contains the code to make the processing of the ingestion. The code is a bit exaggerated. I was preparing this session. I copied from a more complex environment, but in summary, it's loading the ingestion control data to retrieve the last date of the ingestion, generating a custom query and executing a custom query, filtering by the last date of ingestion if available, if not, doesn't filter. Then, uh, if there is nothing, go go out. There is no change to the process, then go out. Okay. Then it breaks down the records according to the change that happened. I'm breaking down the records according to the records are updates or the records are inserts. I could do for deletes as well, but I have not implemented the delete scenario. This is intended only to be an example. There are some specific fixes that I need to do for the customer table. And then I join the information, the insert updated records, inserted records. Then there is the okay, get after field, some processing, and that's it. And finally, I save the table. In this case, I'm saving the customer's table. Okay, let me execute this notebook. I run the notebook. The notebook will be reading the data from custom, processing those changes, which are 3 updates and 1 insert. I think we are on the limit of our time, but I'm already finishing. Finishing is the execution of this notebook. Then the notebook was executed. I can get back to the lake house and make a query over the customer IDs, which I know that I changed. I updated these customer IDs. Let's make a query over them, and we can already see the result. I have two of each one. Two of the 12, two of the 1, and two of the 5. Two of each one of these customer IDs. Okay. And the end date, the previous one, which was there, is finished. The date is being inserted in UTC format, so it's 10 p.m. is being inserted as 8 p.m. And the new record arriving, the new version of the record arriving, is being set as null. So it invalidated the existing record and inserted the new record. And then we have the uh, insert operation, which just brought a new record which was not here before. This record was not present here before and was inserted into this table. Uh, so I'll leave some reference. I wrote an article about mirroring to Fabric. This article explaining details mirroring to Fabric. And there is like a blog post in LinkedIn, published inside LinkedIn, about the data activator execution triggering, which I mentioned during the session. So if you would like to take a screenshot, meanwhile, I'll take a look on the Q&A. It seems there are some questions here. Let me take a look. So, there is one question here from Abdul about SCD. What's the correct approach to handle when there are more than one field which needs to be tracked for changes? Uh, in fact, we are already tracking all the fields, not one field. We are already tracking all the fields for changes. The problem is when you don't want to track all, you want to track only some fields for changes. In this case, on the update operation, on the processing, you need additional code that you compare the after with the before and check if the changes between after and before are in one of the fields that you intend to track or not. So in this case, if the change is not in one of the fields you are tracking, you ignore the change, you don't process the change. I hope this answered the question, Abdul. Well, this is a very different scenario. Replicate of real-time data from multiple shared sources to Azure SQL. I would need to analyze more about this, but if I had to put guess, a big guess, I would guess about some always-on relation, especially if you are using managed instance. An always-on relation would be possible. But this is not related to Fabric. It's only related to replicating SQL to Azure SQL, shared SQL to Azure SQL. There is a technique that it still exists, which is a replication technique using a central subscriber. A central subscriber subscribes to multiple sources and receives data from multiple shared sources. I already implemented before, but never tried in this scenario with Azure SQL. A lot of this is in preview. Mirroring is in preview. The CDC is in preview. The enhanced event string is in preview. So there is this question about the cost of the information of these features. With the features in preview, it's difficult to mention the cost of these features. But I can say that I have mirroring and CDC running in NEF64 and runs quite fine. No problem inside the NEF64. And these are my contacts. These are my contacts. You may would like to take a screenshot, and it will be a pleasure to stay in touch and connect on social media. Thank you very much for attending this session. I hope you all like it. Any feedback is very welcome. And if you have any additional questions and would like additional clarification, just reach to me on social media. Thank you very much.